All right, now we're going to have part 2, Young Marine Explorers. This segment of our program was organized by Dr. Kathleen Sullivan Sealey, a faculty member in the biology department at the University of Miami and Coral Gables. Kathleen has a PhD in marine biology from Scripps Institute of Oceanography at the University of California in San Diego. Her background is in marine ecology and oceanography with applications to marine conservation and sustainable inland systems, and it is her passion for marine science that lined up the stars for her to cross paths with young marine explorers. Here to kick off part 2 and to introduce the next set of presenters, I give you Kathleen Sullivan Sealey.
Thank you, Nick. Thank you, Nick. The world is really looking at the Everglades and at the Everglades restoration. They see what is possible and they take away their own inspirations. So we have to remember that the world is looking at us as we carry on this meeting and we carry on the restoration of the Everglades system. It is my pleasure to introduce Ms. Nikita Shiel-Rolle. Nikita has a bachelor's degree from the University of Miami in marine science and a master's in science in biodiversity, wildlife, and ecosystem health from the University of Edinburgh. Nikita is relentless in her pursuit of community engagement to address the pressing environmental challenges of the Bahamas. As a Bahamian citizen myself, I am passionate in promoting awareness and the fragility of the Bahamian archipelago. It has many similarities to South Florida, and Nikita has captured this and taken her passion to communities throughout the Bahamas. She's a recipient of the Bahamian Icon Award. She's well known throughout the country for her social media savvy, and she has a singular focus on marine stewardship and the underserved communities of the Bahamas. She has recently moved her Young Marine Explorers programs to our family island, the Cat Island community, to build support for coral reefs, coral reef nurseries, and marine protected areas. So I give you Nikita Shiel-Rolle.
Good morning. I'm so happy to be here. Thank you so much for giving us this wonderful opportunity. I am going to be talking today about my Young Marine Explorer story. And this story started 18 years ago when I was 13, and I had my first summer job working at a dive company in the Bahamas, and I fell in love. I was working on the snorkel boat, and that summer I declared that I was going to dedicate my life to protecting the ocean. And in 2007, as an undergraduate student at University of Miami, I founded what was then called Young Bahamian Marine Scientists and is now Young Marine Explorers. And Young Bahamian Marine Scientists at the time was initially dedicated to environmental education and connecting Bahamian youth to the ocean. Our work still focuses very heavily on connecting youth to the ocean and environmental education, and we have taken things up a notch. And so now what we do is we place huge emphasis on engaging community members in all aspects of conservation, whether it's through citizen science, through community meetings, and developing ownership for our natural resources and for conservation. And I firmly believe, and I've recently had a wake-up call about this, but I firmly believe that conservation must come from the heart. And it has to be driven from a place of love. And Marianne Williamson, I think, says the quote best when she says, "In every community there is work to be done. In every nation there are wounds to heal. In every heart there is the power to do it." And I really believe in this, and I believe that my work comes from the heart, and I believe it's through that I'm able to inspire and work with so many youth. And I've had the opportunity to work with over 2,000 youth from all over the Bahamas. And today I am so very excited that I have 2 youth with me from Cat Island, Bahamas. Cat Island is a remote island in the Bahamas. I had the pleasure of starting to work there in 2012, and I recently, almost about 2 years now, made Cat Island my home. And so right now I'm going to invite Kente Campbell. Kente Campbell is a 10th grade student from Arthurstown. Woo-hoo, that's where I live, Arthurstown, Cat Island. And he's going to talk about his experience in YME. So Kente, the show is yours. You're going to be amazing.
My name is Kente Campbell. I'm 15 years old, and I'm at Arthurstown High School. I'm a 10th grade student. Cat Island is a boot-shaped island which is located in central Bahamas. The reason why I love Cat Island is my home, and it has many beautiful beaches, blue holes, and many folktale stories. The old lady on the screen is my cousin, Miss Eula May. She has a story that when she was a little girl, she went to a blue hole and she watched as a woman jumped in the water and never returned. This has led many locals to believe that there are mermaids in Cat Island, as there are many stories pertaining to this event. Cat Island has many mangrove ecosystems. Mangrove ecosystems are beneficial to the Bahamas as they are home to many important fish species and many important food sources, including the queen conch, and also they help protect against erosion from storms. The reason why I joined YME, ever since I was a small kid, I always loved marine biology. I always used to watch Nat Geographics, and I always wanted to go scuba diving and snorkeling like the scientists on the TV. So when Nikita Shiel-Rolle came to our school and she said we'll be doing those exact same things, it was all question that I rejoined YME. My favorite YME after school class was the ocean acidification class. Each student was given 2 eggs and 2 jars. Each jar contained an acid and one contained a neutral liquid, which was water. We were to leave the eggs in the jar for about a week while taking daily notes. After the first day, I realized that the egg which was in the acidic liquid became very eroded, and after a week it became a naked egg. It had no more shell, but it was still intact by the egg membrane. The egg which was in the neutral liquid, the water, became rotten as it enlarged quite noticeably, and it smelled very foul. This class has taught me that excess carbon dioxide in the atmosphere will erode our coral reefs, as our coral reefs are made of calcium carbonate, the same material that the eggshell is made of. My favorite YME ocean class was when we took a snorkeling expedition in Benesaba. Miss Nikita Shiel-Rolle offered to carry us to a reef at first, but first we went to a rock, and underneath a rock in the water we saw a lot of coral and a lot of fish, and after exploring that for about half an hour, she asked us if we wanted to go a little further out. Since everyone agreed, we went to a reef that ran parallel to the shore, and it was there I saw everything I ever wanted to see. All of the beautiful coral, the fish, and everything that came together so beautifully. It was then I actually knew that I loved YME. In YME, we have a number of members who have medical conditions, and we are always exposed to the natural elements of Cat Island. So we took a first aid class in case something was to happen. It took 6 hours to complete, and we learned a lot. We learned how to deal with situations like stroke, heart attacks, seizures, and asthma. But in the end, it was worth it. The Department of Marine Resources held a fish-off on Cat Island, and since YME collaborated with them, we had a mangrove cleanup. We took a very short boat ride to the mangrove ecosystem, and it was there we took several garbage bags and we cleaned up the ecosystem. There were a lot of bottles and plastic bags that were entangled in the mangrove roots and branches. And after we were done, well, on our way back, we saw a lot of spotted eagle rays in the harbor. And after that, two apprentices, Clive and Alfred, were free diving to collect tides out of the harbor because it creates poison for the fish. So a group of YME members went free diving with them. And since I keep repeatedly diving without taking breaks, I almost experienced a shallow water blackout. It was quite a scary experience as I felt extremely lightheaded while returning to the surface. And that event has taught me to always go with a friend or to at least take rest before every dive. Hey. Since we're all citizen scientists, I believe taking data is important in the community, as taking data helps us to get better information instead of going and guessing and getting inaccurate information and making poor decisions. YME has made me an active citizen in my community, as YME has something called paint nights where everyone comes together and just paint and relax, and it's taught me that people love to be together while communicating with their friends. So recently I've been planning a number of basketball tournaments and sports events for the community, and I hope to meet a number of you when I'm done. So yeah.
Amazing. What many of you probably don't know, but I'm going to tell you. So YME actually just started our program in Cat Island 3 months ago. So it's amazing how engaged and involved our students are in such a short period. So just imagine when the students have been through our 3-year program, how powerful and how incredible their conservation leadership will be. So it's really exciting. So my next student that I'm going to invite up is Shamar Thompson, and he is a 12th grade student in Oldbite High. So Cat Island is a very long island, and so we have 2 different high schools. And Shamar is going to be talking about his experience in YME, and his presentation is called My Ocean, My Future. You got it, buddy.
Good morning. My name is Shamar Thompson, a 12th grade student at Old Bite High School. I live in a settlement called McQueen's. It is located in the southern part of Cat Island. I love Cat Island because of its culture and unique people, such as Rake and Scrape. Rake and Scrape is a festival held in June that consists of music made from drums and saws. Cat Island has the highest point in the Bahamas. It is called Mount Alvernia, or some may say Como Hill. It is 206 feet above sea level. It has a monastery called the Hermitage. It was erected by Father Jerome. YME has pushed me out of my comfort zone by doing things I thought I would have never done, such as snorkeling in over 20 feet of water. My YME highlights include conducting experiments, collecting water quality data, and beach profile data. I have a passion for nature. That is why I joined YME, and I believe that if our environment is not protected, there will be no nature for me to enjoy. YME has inspired me to become an active citizen in my community. YME members are learning the importance of sustaining our marine environment and becoming active citizens and stewards of our environment. YME meetings are held 2 hours once a week on Thursdays after school, and our ocean classroom sessions are held in the field for 4 to 5 hours. My favorite ocean classroom session, after school session, was the one that focuses on sandy shores. In this class, we talked about the different zones found on the sandy beach and the different organisms that live in the sand and on top of the sand, such as meiofauna and macrofauna. In this picture, you can see we used a disposable pie pan, and it was sectioned off into 5 sections. The first section was dyed blue to represent the ocean. And the second section, we then laid a layer of pudding down and sprinkled sprinkles on top of it to represent the meiofauna, organisms that live in the sand. After that, we used another layer of pudding to put on top of the sprinkles because meiofauna live in the sand. We then placed fruit snacks on top of it to represent macrofauna, such as crabs. After completing the intertidal zone, we draw a line of chocolate syrup to represent the high tide water mark. A line of seaweed is often found here. The next zone is the pioneer zone, which we added sea purslane, an edible plant found on the shores. After the pioneer zone, we made a fixed stone zone, which was made with sea oats to represent, which was made with oats to represent sea oats. Last but not least, because we were not in the sea grape season, we used a sea grape leaf to represent the scrub woodland zone. In my first YME class, ocean class, it was very difficult because that day the water was very cold and I didn't want to get into it. Ms. Nikita Shiel-Rolle taught us how to float, swim, and snorkel in one day. She made a meditation to help us get comfortable in the water. And that day, even though it was cold, I still ended up joining because of all the fun activities that was going on. On my second ocean classroom session, me and Nikita and Rakadra, a YME member, went on a snorkel trip, and the reef was located in over 20 feet of water. We saw snappers, crabs, groupers, and grunts. To me, it was very exciting. On that trip, I then learned that our reef are actually homes for native fish, and that our coral reef protect them. I saw the different coloration from coral reefs, seagrass, and the different fish and sea ferns. I thought it was amazing to see God's beautiful creation. It's my ocean. A healthy ocean means generation will be prosperous and have a good future. As a citizen scientist, I am understanding the status of our environment and ecosystem and working toward building a resilient community. Thank you.
Wonderful. I think they did such an amazing job at expressing their experience in YME. So what I'm going to talk about now is the wider scope of our Young Marine Explorers program. So when I started Young Marine Explorers in 2007, like I said, it was primarily focused on environmental education. While I was working on my master's in about 2012, I started realizing and asking myself, how do I really enact true conservation action? How do we really conserve things? You know, because it's so easy for us to do things and not really see an impact and just keep doing the same thing over and over again. And so this had me look at some of the main drivers and factors that are inhibiting conservation action in the Bahamas. And this led me to 3 specific things. One is education. In the Bahamas, we have significant education challenges. The majority of our high school students are leaving high school ill-prepared to enter the workforce. We have, for the most part, a functionally illiterate society. And so this makes it very difficult for us to, as a society, to move forward with economic growth, but then also to work towards sustainable development. Secondly, what I've observed is that local communities are not active players in conservation projects, and that local communities need to be active and equal participants in conservation action. Additionally, we have severe data deficiencies when it comes to understanding the status of biodiversity, looking at spatiotemporal trends. That information just doesn't exist. And there's also a lack of capacity, because that can be extremely expensive. And if you're familiar with the Bahamas, we are a very large archipelagic nation. So, to address that, YME focuses on 3 main pillars. We have youth development, we have biodiversity monitoring, research, restoration, and disaster assessment, and then we also have community engagement. So with Young Marine Explorers, what we are working on is that we are developing active citizens and environmental leaders who are taking action, and they're doing this in a number of ways. So 1, they're monitoring biodiversity. 2, they're actively involved in restoration projects and restoring ecosystems. And 3, they're supporting natural resource management and policy. And as I mentioned, we just started our Cat Island community-driven conservation project in January. This is a 5-year project, and it has 3 specific objectives. 1 is to inspire and develop active citizens and environmental leaders. 2 is to collect large data sets on ecosystem health and community perspectives to support evidence-based management and policy making. The 3rd is to develop sustainable behavioral habits that support community-driven conservation, which will lead to creating changes that build environmentally resilient communities. And as you all know, we are a very low-lying country, and so building community resilience is essential, and we need to be proactive and not reactive. And so this is what we're really working towards. And so getting things started, like I said, I am not a Cat Islander, and so I had to engage the community, and I first had to seek permission, because you cannot just enter a community and think you can run a conservation program. And so I went to local government and requested official permission, introduced the project. I then identified key partners, and the 2 main partners that we've been working with has been the Ministry of Education, obviously because our programs are based in the 2 high schools, and also the Ministry of Agriculture and Marine Resources. We then enrolled 42 students, which is approximately 1/3 of the target population that we're working with on the island. And then we also enrolled 8 community members, so that's between 18 and 65, 8 community members in our apprenticeship program. And the really amazing thing about the response from the apprenticeship program is that we have local government officials, fishermen, and youth. So it's a very nice cross-section of the society. And so you heard a lot from Shamar and Kente about our after-school program. And so the curriculum, the Marine Citizenship curriculum, has 7 specific units. And our Marine Citizenship curriculum has been mapped on top of the Ministry of Education's curriculum for biology, math, geography, and language arts. And this is how we are reinforcing the education that students need to know to be successful in high school, and working towards improving our educational output. Additionally, with our apprenticeship program, we are actively working to train conservation leaders. And as I mentioned, our apprentices are a cross-section of society. And what's also really interesting is that our apprentices have a very diverse educational background. We have some who never graduated from high school, and we have one has the highest level of education, who has an associate degree from the Bahamas Agricultural, Marine, and Science Institute, BAMSI, in marine science. And what we're working towards is, again, I always believe, and I firmly believe this, when people are in crisis mode, you can talk to them about anything you want. And I always use the example, if your house is burning down and I'm parked outside and all of a sudden my battery is dead and I come up to you and I'm like, hey, can you give me a jump? Really? You're not gonna give me a jump because your house is burning down. All right, and so this is the same thing that we have to deal with conservation, is that we have to make sure that people's basic needs are met. And until then, it's not possible for us to effectively enact conservation. And so this is why one of our goals is 100% employment of the apprentices that are going through our program, who enter the program without jobs. And I'm very happy to announce last week we actually hired our first apprentice, who is a local fisherman and has now come on board as our community and coral nursery coordinator. So that's very exciting, and we're working with the Department of Marine Resources to hire another apprentice in a joint position. And so, again, our goal is to train and engage high school students and community members in collecting, analyzing, discussing, communicating, and then, of course, restoring or addressing the matters that we learn from the data that we collect. And so one thing that I'm adamant about is that Young Marine Explorers and our citizen science program, we do not use our citizen scientists as data mules. And often in citizen science, this is what happens, and the citizen scientists aren't engaged in the entire scientific process. And I think it is essential because we need to ensure that there is ownership of the resources and that it's an exchange. You know, we benefit from the resources and then we also have to give back. And I think one of the best ways to accomplish that is through engaging citizen scientists in the entire process. So since January 2019, we have trained 50 citizen scientists in both the beach profiles and our water quality profiles. And through a consultative process, which I thought was fantastic, with our apprentices, we identified the 10 study sites, and which was great. Again, coming in, I didn't have the local knowledge. And so it was amazing to be with fisheries officers and fishermen, you know, and people who live and know this island and who could identify what were the best locations for us to set up and use. In addition, so what we have done so far is we have conducted beach profiles of 4 of the 10 study sites, and actually this week as we speak, we have Clive, our new employee, conducting beach profiles. So it's wonderful. And so going back to what I said in the very beginning of the talk, that this work is emotional, and this work has to come from love. And it's personal, because what I'm working to see happen is behavioral change. And if you're asking someone to change what they have been doing for the entirety of their life, you cannot just come up to a stranger and be like, yeah, what you were doing for the past 25 years, yeah, change it. It doesn't work that way. You know, and so this is why we have these paint nights and we do these community events, because it allows us to get to know our community. And what's been amazing is that at these events, conversations organically come up. You know, and this is laying the foundation for what we are now going to be implementing. May 1st is our first talk where we're going to have monthly community conversations where we're going to talk about different subjects. So the first conversation that we're talking about is sea level rise. And what is our plan? Or do we even know about it? Let's talk. So our future plans for Young Marine Explorers in the near future. The first is we've been contracted by UNESCO to produce a policy brief on the implementation and scalability of our YME approach to community-driven conservation and the use of participatory science. Additionally, in that contract, we are working, we'll be holding a stakeholder workshop to do a number of things, which one, improve awareness, capacities, and actions that will result in improved decisions, policies, and coastal and marine programming at a local level, including climate change and adaptation of vulnerable communities, which in Cat Island and quite frankly the entire Bahamas, we are a vulnerable community. Additionally, we are partnering with local government in Cat Island to host Coral Fest. It's going to be a festival celebrating Bahamian natural and cultural heritage. It's going to be amazing. You should all come down. And then also, we are going to be opening Collaboratory, which is going to be a research and community center. And the basis of Collaboratory is that we want to collaborate. And let's work together and, you know, let's enact some conservation and measurable impactful conservation. And so with that said, thank you. I would like to say, because this is an American audience, the U.S. State Department has been one of my biggest supporters from my very early years. So thank you, because that is all your tax dollars. And in addition to, none of this work would it all be possible without, of course, Dr. Kathleen Sullivan Sealey, who has been my biggest champion for a very long time. And everyone else, thank you.
Thank you very much. That was really inspiring. And I also want to add a couple of other thanks. One is to the Loxahatchee National Wildlife Refuge staff and volunteers who hosted them for a field trip on Monday. I think they had a pretty good time getting to see some of the Everglades. And also just again to thank Kathleen, because she also helped coordinate the visit and ferry everybody around and sort of serve as a general guide for those folks. I really appreciate all that everybody did. Okay, our last session is lightning talk, science advancing Everglades resilience and sustainability. As we talked before, engaging youth is one of our primary missions here of this plenary session in particular, and we want to foster professional development of university students as they aspire to further their career and become future leaders in the environmental arena. What we did this time is take each of the three major universities that we interact with. There are others, but we just had to focus on three: Florida International, Florida Atlantic, and the University of Florida, and ask each of them to pick one undergraduate or recently graduated student that would give a talk sort of fitting with our theme of our conference, a 5-minute lightning talk, and then to have a few minutes for questions and answers. And so what we've done, we'll go through 3 of those. We have a microphone on each side, and after their 5-minute talk, we'll just have a few minutes for questions and answers. So I hope a few of you will come up and engage these very bright students and ask good questions. Our first lightning talk presentation is by Mrs. Jordan Waldron, a recent graduate of Florida Atlantic University in Boca Raton. She earned a BS in Biological Sciences with a concentration in marine biology and a certificate in environmental science from Florida Atlantic University in December of 2018. She graduated with honors distinction as a result of completing an undergraduate thesis on her research with Dr. Stephen Kajura in FAU's Elasmo Branch Laboratory, studying the seasonal migration of black-tip sharks to southeast Florida. And exciting now that Jordan plans to continue all of this with starting as a student lab tech, or starting as a lab tech in the same lab that she came through. So, Jordan, thank you very much.
Good morning. My name is Jordan Waldron, and my research with the FAU Elasmo Lab is on the seasonal abundance and spatial distribution of blacktip sharks in southeast Florida. So, the blacktip sharks migrate along the United States eastern seaboard every year. In the summer, they can be found off the coast of Georgia, South Carolina, and North Carolina, although some do migrate as far north, as north as New York. And in the fall, they migrate south so that in the winter they can be found by the thousands directly off of southeast Florida's coast. So my research is interested in this overwintering phase of the blacktip shark migration. We used aerial surveys to record HD videos of the shoreline to about 200 meters offshore from Miami up to Jupiter Inlet. And for video analysis, we split this transect into 7 sections based on easily visible inlet jetties so that we were able to calculate specific shark densities to track their distribution while they're in southeast Florida in the winter. And due to the light sandy sea floor and shallow clear waters within our transect, we were able to identify, distinguish, and count individual sharks either manually or using ImageJ software's counting tool if it was a really large and dense aggregation. And so what we're seeing is that the highest shark densities are within the 2 most northern sections of our transect, so from Boynton Inlet to Palm Beach Inlet and Palm Beach Inlet to Jupiter Inlet. So for 2011 to 2014, the highest density within one section for the entire year all were between Boynton Inlet and Palm Beach Inlet. And except for 2013, because there was a beach renourishment project that muddied up the water, so we couldn't get accurate counts for that year. But then in 2015, the highest shark densities for a section shifted north so that it was between Palm Beach Inlet and Jupiter Inlet. And as you can see, these densities, these highest densities for the entire year, are much lower than previous years. So for example, in 2011, we had over 2,100 sharks per square kilometer, and in 2018, the highest density we had was 324 sharks per square kilometer. So over the past 8 years, we're seeing an overall decline in shark abundance within our transect. So this graph has the years on the x-axis and the highest count for the year on the y-axis. So in 2011, we had, for all sections on one day, over 12,000 sharks, and then in 2018, we had 2,800. And so this doesn't necessarily indicate a decline in the population size of the northwestern Atlantic subpopulation. Instead, it kind of just suggests a shift in their migration patterns, so they aren't going to the areas that they used to be, which are within our transect. And when we compared this overall abundance with the average water temperature between January and April in Southeast Florida, we saw an inverse correlation, and so like water temperature is steadily increasing as we're seeing that decline in shark abundance. And so water temperature could be an important contributing factor to the migration of sharks, whether they're following optimal water temperatures for their own thermoregulation, or they could be following temperature-dependent prey populations. But either way, if water temperature is one of the main factors in the blacktip shark migration pattern, if ocean temperatures continue to rise, it could potentially lead to the migration moving to overall higher latitudes, where the sharks could go to farther north areas in the summers and then not be going as far down south in the winters. And because these are important predators, this could potentially lead to ecological imbalances along the entire United States eastern seaboard. So I'd like to thank the FAU Office of Undergraduate Research, the Honors Biology Program, the Colgan Foundation, my advisor, Dr. Kajura, who is not here, and I'll take any questions.
Questions? Everybody's going to be quiet in the morning. I'll start with one. So can you speak a little bit about the overall role of sharks in the ecosystem? So let's say the migration north or continues to shift to the north. Mm-hmm. What kind of more ecosystem effects would you expect to see?
Well, based on my cute little charts here, I was indicating how if there's more sharks farther north, there could be decline in the prey populations, and then if there's less sharks down here, there could be an increase in the prey populations, and then it could kind of cascade. So
any other questions? One other thing, go ahead, step up to the mic if you would so everyone can hear your question. Phil, it's right behind you.
Are you guys seeing any changes in reproductive activity with the shift in temperature?
Well, they reproduce in the summer up near the Carolinas, so it's not really something that we're looking at, but that is a very interesting thing to look into. Yeah.
Another question? All right. Could you please go to the microphone, because no one can hear you unless you, it's right behind you. Right away.
Is their migration part of the mullet run, by any chance?
Yeah, it could be. It could be one of the prey populations that they could be following. We haven't done any data analysis on when mullet are here and then the sharks are here, but we do see a lot of, in the aerial surveys, we see a lot of bait fish and schools of fish, and the sharks are always near them. So.
Okay, thank you.
So other than the Atlantic coast, are there other studies that are similar to yours that are showing similar patterns or different patterns, like on the West Coast, or is this just the main area?
Yeah, I mean, sharks in general, some of them go through this pattern. In Israel, we're starting a new project because they noticed a migration in sharks pretty similar looking to what our surveys look like. So I'll let you know what happens with that. But yeah, it's a trend that we're seeing.
Good. Any other questions? Go ahead.
Hi. I wanted to know what kind of field work you did and if you have any memorable field work experiences that you wanted to share with us.
Well, the only field work that went along with this project was the survey flights. So I actually only went on one survey flight. And I mean, it was really cool because you could see, all the sharks and all the different marine life that are right on the coast, and people don't realize how close they are, like dolphins and manatees and sharks. And so yeah, that's cool. But The lab in general, we do a lot of like tagging too. So one of the PhD students, she tracks these sharks. So that's how we know that they're going farther north too, because we don't look at that area for mine, but yeah.
Are you involved at all with the, there's media interest always around at least West Palm Beach area. Is it Kathleen, the great white shark?
Yeah.
So are you guys involved with that at all?
No, not really, but we think maybe because, black tips are prey to larger sharks, so maybe they could be eating the black tips, but yeah.
Okay, anybody else? All right, thank you very much, Jordan. That was wonderful. Okay, our next speaker is Mr. Marco Fernandez. He's a recent graduate of Florida International University in Miami, and he graduated with a Bachelor's of Science in Biological Science. He's completed an NSF-funded research experience for undergraduate. It's called an REU, through the Florida Coastal Everglades Long-Term Ecological Research Program under the mentorship of Dr. John Kamenowski. During this REU, Marco led his first research project on the effects of saltwater intrusion into coastal wetlands and the biogeochemical impacts to soil chemistry and microbial activities that affect net carbon balance. As a recipient of the Ronald E. McNair Fellowship and in addition to its 14th cohort, Marco received additional support which allowed him to take a leadership role in another research project to examine how the fire is linked with hydroperiod as a driver for phosphorus cycling and vegetation composition changes in intermittent wetlands, particularly those found along the Lake Wales Ridge of Central Florida, which is what he's going to be talking about with us today, and is a presentation on how fire and water availability drive changes in phosphorus cycling and vegetation composition. Please welcome Marco.
So I guess I'll be moving a little bit away from marine environments and a little bit more towards inlands now. So today I want to talk about how fire and differences in water availability create below-ground elemental changes that ultimately affect above-ground plant communities. So in many systems, such as perennial wetlands, droughts and fires are events that are strongly associated to negative effects to ecosystem productivity. However, these events are natural occurrences in intermittent wetlands, and their role in affecting overall ecosystem growth remains unclear. Okay. So fire and drought can play very important roles. Fire in these ecosystems results in rapid nutrient cycling and plant regrowth, driven by microbial communities and sudden phosphorus availability. And drought, especially in these wetlands, can drive the release of plant soil carbon and other nutrients. So the purpose of this study is to link the role of soil organic matter in nutrient cycling and how that influences plant productivity overall. Fire is a very important tool in understanding these dynamics because of their role of releasing phosphorus, especially in phosphorus-limited ecosystems. So this will bring us closer to understanding the relative roles of soil and plants following a fire on overall ecosystem phosphorus retention. So for this research project, we focus on the native Florida scrub in Archibald Biological Station as a model ecosystem due to its nutrient-limited entisol soils, as well as its reliance on fires as an important nutrient driver of nutrient cycling. Also because of the distinct seasonal inundations and distinct plant soil communities. So my research question is, so how do plants and soils use the available phosphorus by fire in intermittent wetlands that differ in water availability and soil organic matter? So I hypothesize that fire will increase turnover of plant soil organic matter and nutrients. However, soil retention and plant uptake of phosphorus will depend on water availability. So I would expect that the wetlands with longer hydroperiods and are much deeper will be much richer in soil organic matter, which will ultimately lead them to release more organically bound phosphorus during the fire, leading to more percent carbon and percent phosphorus in the plants and soil communities. So this is our experimental timeline. Back in 2016, during the dry and wet season, we collected soil, plant, and water samples. In July of 2017, we burned 8 of the 12 of our wetlands, 4 being controlled. And then during the wet and dry season, 1 year after that, we did the same sampling routine as before. So I'll just go into the results. The first set of results I'll be showing you is water chemistry. Before the burn, total nitrogen, total phosphorus, and total organic carbon. There's a negative trend showing that the deeper our wetlands are, the less present these nutrients are in the water column. After the burn, these This trend disappears, especially because in our more shallower wetlands, the nutrients aren't as present in the water column as much as before. So also for soil phosphorus, before the burn, soil phosphorus was not a function of wetland water depth, but after the burn, that definitely changes. Soil phosphorus increases along wetland water depth, and as you can, I want you to notice that in our much shallower wetlands, they actually decrease in soil phosphorus by up to 50% compared to the shallow wetlands before the burn. So also plant phosphorus I have here, and so before the burn, plant phosphorus increases with wetland water depth. So the deeper our wetlands are, the more our wetlands are able to, the more the plants in our wetlands are able to allocate phosphorus. And that relationship disappears after the burn and becomes far more variable throughout wetland water depth, particularly in our drier wetlands, which is where we're seeing the most changes. And we have a couple, high performers here, and yeah. So we also took these aerial images before and after the burn. So I'll be showing you two different two different wetlands, one of our most driest ones and one of our most deeper and wetter wetlands. So this is one of our most driest wetlands, and so it burned far more completely, far more thoroughly. I ran this through GIS, and as you can see, we characterize these pictures with GIS, characterizing it with emergent mixed vegetation, shore-based vegetation, sand, and other characterizations. And as you can see, the plant communities change drastically in these wetlands compared to what you'll see in our much wetter wetlands. So this is one of our much more wetter wetlands, deeper wetlands. And we also ran this through GIS, and I want you to notice that particularly the areas that were far more affected were in the outer skirts. A lot of it turned into sand, and really the deeper you go into the centers, the deeper you go into the wetlands, the less these plant communities actually change at all, particularly around here. So to conclude, it turns out our results didn't really match our expectations. Most of the changes that we saw were in our drier wetlands. They're the ones that burn more completely, allowing phosphorus to cycle within the system, causing more changes in the above ground plant communities than our longer hydroperiod wetlands. Also it's quite unfortunate that Irma pretty much hit right when we were running this experiment, so a lot of the changes can possibly be because of that. Thank you very much.
Yeah, it's normally with field experiments, it seems like fire is the thing that messes up your protocol, and here you have fire and then a hurricane.
Yeah.
Any questions for Marco? I'll start with one. I want somebody else to be ready with one after that. Do you have a question? Oh, good. Go.
I'm wondering if fire intensity plays a factor in your study, and if you didn't study the aspect, what type of results would you expect with fire intensity, especially when thinking about prescribed fire versus wildfire in dry season?
Right. Well, I would imagine that fire intensity does play an important role. Particularly since I would imagine that soil moisture in our dry wetlands is a lot less, and therefore the fires burn far more intensely in our dry wetlands, and that might be the reason why we see a lot of changes in the plant communities compared to our wetter wetlands, which didn't really burn all that cleanly or thoroughly as well as our dry wetlands, and so that also might be a factor when it comes to comparing the different plant communities of both these wetlands. But yeah, I mean I didn't really look at exactly how fire intensity might have played a role, but that's a really good point that you make. Thank you.
Thank you. Anybody else?
So I was just curious how analogous you think the experiment on the Lake Wales Ridge would be if we move farther south down into the Everglades, because the soils are very different, if I'm not mistaken.
You're right. Yeah, they're incredibly different. The soils here are far more richer in organic matter, so I would imagine that there would actually be more release, as my expectations were for this original experiment, that because they're much richer in organic matter in southern Everglades, I would imagine that there would be more release of phosphorus, causing more nutrient cycling than you would expect here with these very nutrient-poor soils. So that would be, yeah.
Do you think it affects the intensity of the fire at all? That's something I really don't understand. Like, if it's on sandy soil in Lake Wales Ridge, is it less likely to burn as intensely because the peat provides fuel? Or I was curious about that, like how it affects the intensity of the fire too.
Yeah, I mean, to be quite honest, I don't really exactly know the answer to your question, but that's a really good point, and I'd love to look more into that. But thank you for bringing up that point.
Thank you.
Hi. So it seemed like you had more soil phosphorus where you had deeper water and less plant uptake. Do you think if you had flowing water, moving water, you would have seen lower levels of soil phosphorus because some of that might have gotten carried away following the fire?
Well, yeah, I would imagine that, but also I feel like it might have mimicked flow in a sense, because as a matter of fact, you know, I was talking to, we were talking to some of the Archbold scientists, and it was very inundated after the hurricane. So I would imagine that there's got to be some sort of flow effect involved, and some of our results might be because of that. So I mean, I wish I knew exactly what the role of the hurricane played on our experiments, but yeah.
Did it flood to the point where the water level was above?
Oh yeah, no,
okay.
It flooded to the point where it was just completely inundated. I'm sure there's a lot of, it definitely homogenized the landscape a bit, a lot of mixing and matching of nutrients. But you know, we ran AIC models and ANCOVAs, and it did show that we did have a fire effect on a lot of our wetlands. But you know, the hurricane, you know, it's just made things very difficult. But thank you. Thanks.
Okay, we'll do one more.
Hi, so you measured total nutrients. How much of that do you think was bioavailable to the plants and the microbes?
So we also measured dissolved inorganic nitrogen and SRP, and I believe that a lot of it was bioavailable, and a lot of it actually got into the soils and into the plants. I need to look back into the data, but yeah, thank you.
All right, thank you very much.
Thank you.
All right, our final presentation is by Ms. Elizabeth Garcia, a senior undergraduate student majoring in wildlife ecology and conservation at the University of Florida. Her interests include avian and mammalian ecology and conservation, effects of urbanization on carnivores, and human impacts on coastal environments. She spent the summer in 2018 in Everglades National Park as an Everglades BioCorps intern, working on various projects and continues research on food webs in the Everglades. She has worked with avian and mammal ecology labs, where she assisted with graduate student research on hierarchy and mixed avian flocks and analyzing camera trap data to assess patterns of mammalian carnivore distributions in the Pack Tiger Reserve in India. Is it Pack or Packy? Packy Tiger Reserve in India. Elizabeth is an educational outreach coordinator for the student chapter of the Wildlife Society, vice president of GREEB, Gators Ready for Exceptional Birding Experiences, and an artist for the Rattlesnake Conservancy. And in the summer, she begins a stint as an environmental education intern at Ding Darling National Wildlife Refuge. And today she's going to talk about understanding native species resilience to invasives in the greater Everglades ecosystem. Welcome, Elizabeth.
Good morning. Thank you for coming. So, as we all know, of the hundreds of species that live in the greater Everglades ecosystem, unfortunately, many of those are non-indigenous, including the Old World climbing ferns, the jaguar guapote, and the infamous and everyone's favorite Burmese python. So, we've been studying invasive species in the Everglades for decades, trying to figure out how they got here and, more importantly, how to get rid of them, the million-dollar question. And our approach to it is by analyzing food web complexity to see how native species build up or even have resiliency against the invasives based on the structures of food webs. I'm going to start with the basics of what a food web is. Well, within each food web is a food chain. So it's a singular path that energy and nutrients follow throughout the system, and food webs contain multiple pathways for these nutrients and energies to flow through, and that is what we are interested in, these various connections. So here we have a simple food web versus a more complex web, the obvious difference being the number of average path lengths between them, which just means that the average output per input into the system, such as carbon, it's like the number of paths it takes to exit the system. So here's another example of a complex food web, and I'm going to introduce a predator into the system, of course the Burmese python, and let's say that over time species F disappears. This is due to the added predation pressure from the Burmese python. It doesn't seem to have that much of a significant impact. Species H does lose one prey item, but nothing too significant. Then as time keeps going on, species H disappears as well. And now species I has less prey availability, and this is starting to increase predation pressure on the remaining prey items. And I has to compete now with G and the python for species D and E. So time keeps going on, the python stays in the system, and species G is gone. Now species I only has one prey item to choose from, while the python still has two. And this adds severe predation pressure to species D and species E. And a dramatic conclusion to that would be if species D and E completely disappeared. But as you can see, based on these events, just the introduction of a foreign predator can decrease the number of species drastically at each trophic level. And it is through these introductions that it can disrupt or imbalance the ecosystem, and that is what we are really interested in, because our food web would look more like that. So what we are trying to create is a high-resolution, up-to-date ecological framework, and it can be a reflection of the functionality and structure of ecosystems, food webs in the greater Everglades ecosystem. Using previous published literature, we want to create an open access framework that is driven by data that's been collected from previous field work, where we just go out and we find papers that talk about literally every paper on whatever species we're interested in, seeing what they're eating, what time of year is very important, because the food webs depend heavily on the numbers of linkages or relationships, the strengths of these relationships, when the foreign species is introduced, what trophic level it's introduced, and there's so many variables that go into it. And what we are hoping to do is make this an open access framework, so that way it can be used in all types of interdisciplinary research, whether it's network ecology, hydrology, and it can be an overall powerful tool for risk assessments to understand the resiliency of these ecosystems, whether they're already susceptible to invasion. And thank you.
Questions?
Hello, thank you.
Hi.
I'm appreciating the diversity in the Everglades, and I'm thinking about how much we might not know about some of these species. So is there a way for your model to check whether its estimation of resiliency is accurate?
Well, what we're hoping is, like as you can see, it's going to be a very complex food web, and the idea behind it would be that the more connectivity within the system, it could reflect the more diverse the system is, the greater the resiliency it is. But what's really important too is the strengths between each node or each species. So, and it also depends the year, or like the season, breeding season, what stage of reproduction or growth each individual is. So it's still in the works. It's definitely a very big bold project to tackle, but I feel when it's accomplished that it definitely can reflect how well of an indicator it will be for resiliency and biodiversity. Thank you. Hi.
Hi. I have a question about which invasive species has the greatest impact on the Everglades, and then is there any positive impacts of any of the invasive species you studied?
Well, I don't know which species is the most impactful. I would say the Burmese python, but of course you have to think of marine systems with the freshwater systems as well for the jaguar guapote, the armored catfish. Like, that's a whole other world that I don't know too much about. So maybe terrestrially it could be the Burmese python that's very destructive. There's also, outside of the park, the black and white Argentine tegus. So depending what systems you're looking at, definitely each seems to have their own invasive species that's doing the most harm. As for positives, I personally don't know of any positive impacts the invasives are having. So sorry. I don't know.
And
good presentation, so I have two questions, if that's all right. One's
Yes.
sort of a fun one because I'm curious.
Oh, good, fun.
And then the second one's more serious. So the first one, for the fun one, you had that nice diagram of the more complex ecosystem that's more like our Greater Everglades one. What was the red dot?
Oh, this red dot?
Yeah.
This is just a fun picture that my advisor gave me. So
Gotcha.
I would, well, it could start with like paraphyton. It could be at the very bottom of all things. It depends to if this is an aquatic or terrestrial.
Sure.
It could be producers, plants, anything you
Gotcha.
want it to be, depending
Okay.
on what you're
And
looking
so
at.
you mentioned that, there's a number of invasives and different models, and I think you mentioned you might be collaborating with others, and do you have like an open framework for how you're
for open
doing
access.
that? Yeah.
What I
for
meant by
open
that.
access, yeah.
So what we mean by that is what we're hoping to make a publicly available page that people can actually go on and click, and you can see the actual food webs, and it's still in the works as to how that'll visually look, because if anybody sees that, that's scary. But it's more so if you're doing research that pertains to the Everglades, you can go and see, well, this is what my species impacts and what's impacted by it. And so it'll be really great for invasive ecology as well to see if this catfish, this armored catfish comes into the system, let me see what we know that it's been proven to be eating and see how it's impacting all the other nodes or trophic levels below or above.
okay, I got one final question for you. We have
Yes.
this big experiment going on in Everglades National Park that was thrust upon us, where we, because of the python, have lost most of the small and medium-sized mammals. So there's a huge food web experiment underway right now, which I don't think many of us are looking at, or anybody's really looking at. You have any guess as to what the first outcome of those shifts might be? Just to, what do you think the first big food web change we might see from the disappearance of all these probably herbivores and other predators?
From what I know, the rodent population, the rats, seem to be pulling through, and a majority of it is rabbits and birds, but what I think the outcome would be after putting it together is definitely, like you're saying, a big decrease in, could be the primary consumers, and it's going to create more competition for whatever's available. But I feel like there's going to be like those big gaps, like how I showed, where the trophic levels have less and less species. So it's going to be very gappy, is what I would say. It could be not as diverse anymore. So.
Thank you very much.
Thank you.
We'll do the photos after. All right. If nothing else, I hope you are inspired. I mean, that was just a wonderful array of presentations by some very talented youth, and I can say that we have hope for the future, great hope. Good reason to be excited and optimistic and know that the world will be passed along to good hands when you see this kind of effort already underway, both in the U.S. and our neighboring with our Bahamian neighbors. So a couple of quick announcements before you leave. Remember, no matter what, please approach these folks around the break that we're about to go to, and anywhere else you might see them during the day or tomorrow. Engage them in conversation and talk to them. For those of you that we didn't get photos of, please hang around and we'll quickly get some photos on stage if we didn't already do that. Please remember to take time to visit the poster presentations that are going on this evening. And remember, it's a big bedlam in there and a lot of noise and everything, but we'll divide it into 2 sections, like with the odd poster presenters buy their posters first, and then the even poster presenters next. And so I just ask you to, with one big round of applause, thank all of our young presenters today.